can a narrow-body plane actually fly non-stop from a distance like New York to Rome? It sounds almost unthinkable and impossible. We've always associated these long-haul routes with wide-body jets like the Boeing 777 or the Airbus A350. However, Airbus is about to change everything with the A321XLR. And what seems like an impossible leap in aviation is now becoming a reality. But what makes this aircraft so different? And why is it causing such a stir across the aviation world? Let's begin with a feature that truly sets the Airbus A321XLR apart: its range. This narrow-body jet can fly up to 4,700 nautical miles, a distance that was once reserved strictly for wide-body giants. With this capability, it can connect cities like London and Miami, New York and Rome, or Sydney and Kuala Lumpur on a single tank of fuel. But the range is only part of the story. Airbus has also re-engineered multiple components to make the A321XLR a true long-haul contender. At the heart of this transformation is a specialized rear center fuel tank, also called the RCT. The RCT is a specialized system that allows aircraft to carry significantly more fuel than a typical narrow-body jet, extending its reach without sacrificing valuable cabin space. Unlike standard fuel systems, the RCT is designed to hold the aircraft's reach by up to 15%. This also means that the A321XLR will be consuming 30% less fuel per seat compared to the previous generation competitors, and at approximately half the trip cost of modern wide-body planes. Positioned low in the fuselage, the rear center tank is protected by an extended belly fairing, a structural shield designed to safeguard the tank in the unlikely event of a belly landing. This isn't just about range, it's about engineering a safe and reliable system that can withstand the demands of transatlantic flights. Now, to support the aircraft's long range, the A321XLR is also equipped with reinforced landing gear to handle the added weight, and a streamlined belly fairing to ensure stability when the aircraft is in the air. This modification may seem subtle, but it's essential. With a maximum takeoff weight of 101,000 kilograms, higher than the standard narrow-body aircraft, the A321XLR needed landing gear robust enough to support its fuel and passenger load across long distances. This ensures stability and strength, even under the extra strain of heavier loads. And then there's the water and waste management system, another seemingly small detail that's crucial for long-haul comfort. For flights lasting up to 11 hours, efficient water storage and waste management are essential. Airbus has upgraded these systems specifically for the A321XLR, allowing it to support extended operations without compromising passenger amenities. Safety, of course, remains paramount. In fact, Airbus has made significant structural adjustments to meet newly introduced FAA safety standards. The fire protection system around the fuel tank has been reinforced with fire-resistant materials designed to contain any potential risk during emergencies. This layer of protection aligns with stringent regulatory requirements, reflecting Airbus's commitment to passenger safety on these extended routes. All of these features come together to create an aircraft that isn't just built to go farther, but to do so with efficiency, safety, and comfort in mind. When compared to Boeing's closest competitor, the Boeing 737 MAX 10, the Airbus A321XLR stands out with its extended range of up to 4,700 nautical miles, surpassing the 737 MAX 10's limit of around 3,299 nautical miles. This additional range allows the A321XLR to connect distant destinations and transatlantic routes that would be out of reach for the MAX 10. In terms of power, each engine on the A321XLR produces 156 kilonewtons of thrust, giving it a total thrust of 312 kilonewtons. This added power supports its higher maximum takeoff weight of 101,000 kilograms compared to the MAX 10's 92,000 kilograms, enabling the A321XLR to carry enough fuel for longer routes while maximizing passenger and cargo capacity. But that's not all. The A321XLR also provides airlines with flexibility in seating. While both the A321XLR and the 737 MAX 10 can hold around 200 passengers in standard configurations, the A321XLR can accommodate up to 240 passengers in a high-density layout, slightly more than the MAX 10's 230. This makes the A321XLR an even more versatile choice for airlines needing additional capacity on certain routes. Interestingly, as Airbus rolls out the A321XLR, airlines worldwide quickly recognize its potential, but it's not just any aircraft they're adding to their fleets. The A321XLR is opening doors to routes that, until now, were simply out of reach for single-aisle jets. Take American Airlines, for example. In 2019, the airline placed a significant order for 50 A321XLRs, with plans to use them on premium cross-country routes, replacing older, less efficient aircraft. For Americans, the A321XLR isn't just about efficiency, it's about offering a wide-body experience on a narrow-body jet for high-demand routes like New York to Los Angeles. The added range means these airlines can also travel to secondary European cities where larger, wide-body aircraft aren't economically viable, and they're not alone. Iceland Air is also adopting the A321XLR to connect Iceland to cities across North America and Europe. For an airline based in such a geographically unique location, the A321XLR is more than just a new aircraft. It's a bridge linking Iceland to previously challenging markets to serve efficiently while optimizing operational costs. Then there's Vietjet, Vietnam's largest low-cost carrier. The A321XLR allows the airline to expand its long-haul network across Asia and beyond. With this aircraft, Vietjet can offer direct flights that would typically require a stopover, providing a competitive edge in the budget travel segment. In total, Airbus has secured over 550 orders for the A321XLR from 25 different airlines, a clear indication of the demand for an aircraft that can do what no other narrow-body jet has done before. For the airlines, it's about flexibility. For the industry, it's about a shift in how we think about long-haul travel. And for passengers, it's the promise of more options, more routes, and a new level of comfort on journeys that once required a much larger aircraft. So, with airlines worldwide embracing the A321XLR, Airbus needs to rethink its production process to meet with the unprecedented demand. First, Airbus has retooled its facilities, especially at its production site in Hamburg, Germany. Here, the assembly process has been transformed to accommodate the unique structural components of the A321XLR, particularly the specialized rear center fuel tank that gives the aircraft its impressive range. In a former A380 hangar, Airbus has established a dedicated production line equipped with state-of-the-art tools and technology to meet with the precise demands of this long-haul narrow-body jet. One of the standout features of this new assembly line is its focus on ergonomics and efficiency. Airbus has implemented advanced lifting platforms to provide workers with optimized access to the aircraft, reducing the need for uncomfortable positions and increasing assembly precision. The floor grid itself has been designed to allow for vertical assembly, which not only improves worker safety, but also enhances production speed and accuracy. In addition to ergonomic improvements, the Hamburg facility incorporates sustainable practices that reflect Airbus's commitment to environmental responsibility. Large photovoltaic panels on the hangar's exterior generate renewable energy, while noise containment measures and energy-efficient systems help reduce the facility's overall environmental footprint. More importantly, each section of the A321XLR is assembled using a combination of laser-guided systems and sensor-controlled measurement tools, which allow for unparalleled precision. With complex parts like the rear center tank integrated directly into the structure, this level of accuracy is essential. Airbus has even reconstructed its supply chain to ensure timely delivery of critical components, coordinating with suppliers to meet the high standards required for serial production. As Gary O'Donnell, head of the A321XLR program, puts it, "Our industrial system is one of the most complex and dynamic in the world." This advanced setup is more than just a production line. It's a carefully orchestrated system designed to support the ramp-up of the A321XLR and meet the high demands from airlines worldwide. With the new assembly line in Hamburg now fully operational, Airbus has laid the foundation for the A321XLR to enter service efficiently and at scale, marking a major milestone in both innovation and production capability. So now, again, Imagine a world where passengers no longer have to connect through crowded hubs, but can travel point to point across continents, even from smaller airports. That's exactly why the Airbus A321XLR is astonishing everyone in the aviation industry. But we would like to hear your thoughts. What do you think? Will the A321XLR achieve this ultimate goal? Or is this another destined to fail project? Don't hesitate to leave your opinions in the comment section below. And while at it, please click the thumbs up button, subscribe to the YouTube channel, and ring the notifications bell so you do not miss out when we publish amazing videos like this one. Thank you for watching, and bye for now.